Today we'll be tracking exploits in Python. We'll be exposing hidden security vulnerabilities that renders MySQL injections. Open source libraries make up a significant portion of most applications code. In 2010, a Japanese developer, Masato Kinugawa, discovered a serious flaw in Twitter in the form of cross-site scripting, or XSS hack. He set up a Twitter account at the rate Rainbow Twitter and showed that XSS can be used to send tweet in multicolors. According to Veracode, the leading app security partner for creating secure software, third-party software security is a major concern. Even internally developed applications rely heavily on third-party code. Veracode's State of Software Security report indicated that between 30 and 70% of applications that are thought of as internally developed are actually comprised of third-party libraries and components. Recently, in May 2020, in the latest State of Software Security report, Veracode has again pointed out that open source libraries are ubiquitous and risky. Most of the applications that are developed nowadays contain vulnerable open source libraries. In 46.6% cases, these vulnerable libraries are pulled by other libraries indirectly. Those who are calling these libraries, probably they don't know that they are being exposed to some vulnerabilities, or might be they end up using more libraries than they actually require. Applications built in Python has a transitive dependency of 41.9%. Now let's review their core software engineering practice. Once a software project planning is completed, the project managers are supposed to document their plans in Software Project Management Plan document. A substantial part of SPMP is supposed to cover the risk management plan. Risk management, depending upon the project importance, should cover up risk analysis, identification, estimation, and abatement procedures. There is a lot of scope of research in this part, but the problem is time. In software engineering, we rely heavily on metrics that tends to estimate the time of completion of the project from the beginning. So we have lines of code, critical path method, project evaluation and review technique. All these are revenue focused. In third-party developed codes, there is no control. The main purpose of using the third-party libraries is again less time and effort. Also, we have to rely upon blindly. When we use third-party codes, implementing configuration control and version control is a mockery. So to demonstrate an exploit in Python code, I'll be using the database car. We can see that there are two tables, CMAST and rental. There are records in both the tables. The following is a demonstration of how customer database can be compromised by blindly relying upon third-party codes. We will execute some Python command and also update the MySQL table CMAST. We are not going to try any common MySQL injection command as shown here. Neither we will try to build a custom Python package and import the sim and raise the concern. What we will do is put some line in the codes and make it look perfectly meaningful in some way. The code will be there waiting for us to exploit. Will the software project management security be applied to third-party codes? Probably no. The result? Just see yourself, first the code, then the result. The code is shown here. It looks perfectly normal. There is a series of functions written. And this is the entire code that is displayed. How the entire thing will be embedded in the code is actually an art. But this exploit takes the advantage of the present flaw in the system. Here we can see the code is running. It is asking for the name and we are asking what is the name of the current database, and it is displaying. It is showing the name of the tables under the database. It is displaying all the columns from a particular table. It is also displaying all the records from a table. Here we are giving a different option between 0 and 1 and we can actually update the table. Here we have deleted all the records from both the tables.